Hello everyone, welcome back. So today I will be solving a very interesting problem related to binary trees. So it is also today's LeetCode challenge problem called populating next right pointers in each node. So let's go through the problem statement. It says you are given a perfect binary tree where all the leaves are on the same level. So basically what this perfect binary tree means, it means it has every node, or at each level it has all the nodes. Like this example, at each level all the nodes it has. So this level 4 nodes are there, this level 2 nodes are there. So at each level 2 to the power that level's nodes are there. So it's like it's 0 level, so 2 to the power 0 1 node. It's 1th level, 2 to the power 1 2 nodes, and so on and so forth. So it is perfect binary tree. So a perfect binary tree will be given, and the structure of the node is slightly changed, where it usually has a value, a left and a right pointer. Here we are adding one next pointer. We don't have to add this, it is already added in this code, and what we actually have to do is populate this next pointer of every node. So by default each pointer points to by default all the next pointers are set to null, and what our task is to do is we have to point each node's next pointer to its next node. So it will be much easier if you just look at this image. Like this tree will be given, and we have to populate the next pointer of each node to its just right side node. Like this one doesn't have anything on the right side, so that's why it is pointing to null. This 2 has 3 on the right side too, so it is pointing to 3, and so on and so forth for all these nodes. And the last nodes over here are pointing to null, all the last nodes, because it does not have anything on the right. So we will be given the root of this node, root of this tree, and we have to populate all the nodes over here. So follow-up question is, you may use only constant extra space, and recursive approach is fine. You may assume implicit stack space does not count as extra space. So we have to do basically in linear time and using only the stack space as the extra space, no auxiliary space required. So how we can solve this problem? Let's go to the whiteboard and let's see. I have written down the example from LeetCode over here. So here we can clearly see once again the problem statement very clearly. Like each node will be pointing to its right node. It does not have anything, so null over on these 3 nodes, and all the other nodes are pointing to its right adjacent. Like 2 is pointing to 3, 4 is to 5, 5 is to 6, 6 is to 7, and so on. We just have to make these connections. So now just by looking at this problem, the first thing which should come to your mind is, we can see that if we do like a level or a traversal, so the level or a traversal will look something like this. I'm just drawing a dotted line like this, a dotted line. So if we do a level or a traversal of this tree using BFS or breadth first search, we see that each level we get the next node while doing the breadth first search or level or traverse. So like at first level we get 1, at second level we get 2 3, at third level we get 4 5 6 7. So if we somehow modify the code of breadth first search or level or traversal, and we keep on getting nodes of each level and just start like connecting the next pointers, then our job will be done. But now, if I do a little recap or a little explanation on how breadth first search in binary trees work, or rather how the level or traversal work is, we basically take a queue. So basically we take a queue. I'm drawing a queue like this, and what we do is basically first we put the root node over here. So 1 is here. So after that we pop this node. So we pop this node, and we print it over here, and we see if it has the left child and right child or not. If it has both child, first push this child in the queue. So this is popped. Now this is over here, and this one is over here. So this one is over here. Now the next iteration, we see if 2 has left or right or not. So if 2 has left and right, so we first pop 2 and print it over here, and then push 4 and 5, then 4 and 5, and so on and so forth, and we will get all the nodes over here. Now if we do like this, there is one problem. And what is that problem? if you observe carefully, we see that after 1, the immediate next node coming is 2. So if we just by this logic do the traversal like 1, 2, 3, 4, 5, 6, 7, 8, 7, then by this logic if you do, this 1 will be now pointing to 2, but this is not required, because if you do the simple BFS, what is happening after 1, because this level we have only one node, 2 is coming, so by default the 1 will be now pointing to 2, but this is not required. See, 1 should be pointing to null. So somehow we have to modify this logic so that we can put some constraint over here to check if the nodes which are coming are of different levels, then we do not connect them. So how we can do that? We can simply do this by adding another attribute of our another attribute to like our list over here or our queue, that is the level. So whenever we are putting or any element in the queue, we will put the value of that element or the node of that element and also its level. So this is level 0, this is level 1, and this is level 2, right? 0, 1, 2. So first of all we are putting over here 0, 1, and its level is 0. So first of all we are putting like this is 1 and 0. So after that we pop this and we print the value part of this tuple. So we print 1. So after that this tuple is popped from the queue. Now we come to its left. This value is left, we have 2. So now this 2 will be not only inserted, it will be inserted with its level. So its level will be now 1. So 2 comma 1. So after that, whenever we are popping this node, immediately we check if there exists any element in our queue. We take that element and we check the popped elements level and the existing element which is just next to the popped element have the same level or not. In this case they are not having same element. This is 0 and this is 1, so we do not connect them. So we keep on doing our BFS. Now this one, sorry, before popping this one is also added because this has left and right both. So this is also 3 comma 1, right? This is also added. So now we pop this one, so we take this over here and we check its next node. So its next node is this one, and the popped node over here and the next node over here having the same level value, which is what, 1 in these both cases. So that means these two are present in the same level. So now what we will do is we will populate the next pointer of the pop node to the pointer of the immediate next node which is present in the queue. So like that we will now connect these two next to 3, and same way now we pop 3, we take over here and its right and left are uh, inserted in the queue. So it's 6 comma 2, and over here this is, sorry, because I have missed one point before this node's left and right will be also inserted because this is getting popped. So 4 comma 2, 5 comma 2, and then whenever we are popping this, so it will be 6 comma 2 and 7 comma 2. So now this node is popped. So here now we check again, pop nodes level and forward level, they are not same, so we do not connect anything from here to here. Now this is getting popped, so 4 comes here and it does not have anything left or right, so we do not need to insert anything. So whichever value is getting popped, we checked the immediate next, the level are same, 2 and 2 over here, so we connect. So 4 to 5 we connect. Now 5 is coming here, it does not have anything, so do not add anything. So the level of pop node and next are same again, so again we connect, and so on and so forth. We keep on doing this. And just because it is also mentioned in the question is all the nodes are having null as the next value by default, so we do not need to add anything for this terminal nodes like this one and this one, because they're already pointing to null. We just have to rewire kind of in the intermediate nodes, and this is how we can just use some simple logic to check the levels of the nodes to determine which levels or which nodes we need to connect together or which nodes we don't need to connect together. So this was the logic, and now let's go to the code editor and let's see how we can code this using Python. So now I will be explaining how to write the code of this solution which I have explained in the whiteboard. So first of all, I am doing a very basic base check over here. If the given root is none itself, then we are simply returning the root. We don't need to anything do. We don't need to do anything. So after that, we are taking a queue using the DQ in Python, or if you are doing in Java, you can take the queue from collections. So this DQ, we are first inserting the root and its initial level, which is 0, and we are inserting it as a list. So it will be a DQ of list or queue of list, which is having only two elements. Okay. So after that, we are doing just simple BFS or simple level or traversal, which we usually do. First of all, we are just popping and we are storing it as current node and its depth. Then we are checking if the queue has any element, then whatever element is at the front, that means what, it is the just next element of the popped element, right? If it has any element, so that is why we are storing the next node and its level in these two variables, next node and d. We don't need to pop it, we just reference it and store it over here like q of 0, and we are checking this step. This is the main trick which I have also explained, that whatever node we are getting as next node, its level which is d over here, and the previously popped node which is depth, if they are same, then only we connect the pop nodes, which is current dot next equals to the next node which is inside the queue. This is the wiring part, and after that these two lines are pretty much the same thing which we do in level or traversal. We check if the left and the right exist, then we insert the left and right with incrementing the depth plus 1 because it is in the next level, and after that wiring the whole thing, we are returning this root. So let me submit it. So here we can see it's getting accepted. So what will be the time and space complexity of this code? We know that the DFS or BFS of any tree is of order of n. So it will be of big O of n in time complexity, and we are using this queue as extra space, but this is not considered as extra space because it is mentioned over here that if you are using any recursive approach, the stack space, or in case of BFS, the queue space is not considered as extra space. So this will be considered as big O of one space. So this is my solution. I hope you understood how to solve this problem, and if you did, please make sure to press the like button and subscribe for more. Thank you.